Okay, this is Jalen Pan, and this is a video for the probability and stochastic processes homework 2, problem 2. Okay, let's come to this problem. Okay, in this problem, we have one signal called x1, and we have several noisy channels. After the first noisy channel, the signal becomes x2, and after k noisy channels there's xk, and the output is xk plus 1. Okay, we have the probability that x1 equals to 0 is 0.2, and px1 equals to 1 is 0.8, and for all k bigger than or equals to 1 and smaller or equals to n, there is a conditional probability that xk plus 1 equals to 0. In the condition of xk equals to 0 is 0.6. Okay, let's come to this first question. Is find p x2 equals to 1. Okay, this is the solution. We know that p, the probability that x2 equals to 1, have two possibilities. The first is that x2 equals to 1 and x1 equals to 1, and x2 equals to 1 where x1 equals to 0. So there are two conditional probabilities, and each of them is exclusive. So however, to keep this solution simple for the B, C, D questions, we can write it down with the form of a vector and a matrix. So we can find that there's a vector that the first element is px2 equals to 0, and the second element is px2 equals to 1. We write it down like this is a vector, this is a matrix, and we write it down that this multiplies and the result is 0.36 and 0.64. So p, the probability that x2 equals to 1, is 0.64. Okay, we come to the second question. The second question is that we should find the probability that x3 equals to 1. Okay, we use the matrix and the vector in the first question, and we can write it down. After the second noisy channel, we have x3, and p x3 equals to 1, p x3 equals to 0. We can write it down with the vector and matrix. However, we can see that after the first noisy channels, we have x2, and we can just write the matrix down and it multiplies with it again. That's a power 2. So we write it down, the vector and the matrix with power 2. And the result can be calculated at 0.408 and 0.592. So the probability that x3 equals to 1 is 0.592. Okay, let's come to the third question. The third question is that we should find the conditional probability that when x3 equals to 1 and x1 equals to 0. Okay, we write it down. According to the conditional probability, we should write it down that p, when x3 equals to 1, x1 equals to 0, can be written down as p x1 equals to 0 and x3 equals to 1 over p x3 equals to 1. We already know that according to the second question, p x3 equals to 1 is 0.592. So we write the upper and calculate it as we should change the two positions, and p px1 equals to 0 and x3 equals to 1 is px3 equals to 1 when x1 equals to 0 multiplies px1 equals to 0. So this conditional probability we have already calculated. It's 0.52. Okay, and px1 equals to 0 is 0.2. So px1 equals to 0 and x3 equals to 1 is 0.104. So write it down. P when x3 equals to 1, x1 equals to 0 is 13/74. That's 0.76. Okay, let's come to the last question. The last question, we should find pxn equals to 0 when n comes to the infinity. This is a very simple question, because we should find that when n is large enough and it comes to the limitations of xn equals to 0 when n comes to infinity, we should know that after enough noisy channels, and the probability doesn't change anymore. So we should find out, we assume that the limitation is a, and the limitation is that xn equals to 1 should be 1 minus a. So we use this matrix again, so we should know that after enough noisy channels, this probability won't change anymore, which means that this probability, this vector, multiplies with this matrix. It comes to the output, it's itself, and doesn't change anymore. That's a very simple question, so we write it down, we calculate it, so the a is 3/7. So the limitation that pxn equals to 0 when n approaches infinity, that's 3/7. Okay, that's the question. Thank you.